Okay, welcome back. So we're going to work on example C that was on that same page that we started with. And example C said this: dy dx equals x times y. Let's find the solution to this differential equation. It means we need to solve for y. And we're going to have to take the integral somewhere. But again, remember, we have to get it so that there's the y's on the bottom and the x's on the top somehow. Now, it won't look just like x over y, but that's the idea. You want to have the x function or x variable somehow on the top, and you want the y function or y variable on the bottom. Okay, remember we did on part B where we moved things around with negative powers? It's going to be the same idea. Let's change xy. Right now, xy is xy over 1, right? 1's on the bottom. Now, that's good right now because the x is on top. That's great. I'm going to leave him as is, but I need to somehow move the y on the bottom. And the way we can do that is by changing the power to a negative exponent. So how about xy over 1 equals x over y to the negative 1? Now, doesn't that make sense? Because if I want to bring the y back upstairs, he would become a positive y variable, a positive y exponent. So that's good. All right, we're good to go. We have dy dx on the left side, and we have x over y to the negative 1 on the right side. The x's are diagonal, the y's are diagonal. Let's cross multiply. All right, this becomes y to the neg 1 dy equals x dx. X's match, y's match. Here we go. Integral, antiderivative both sides. Now, that's a tricky integral on the left side. Y to the negative 1 is the same thing as 1 over y. And x is just x. So the right side I think is going to be pretty easy. But, do you remember, what's the antiderivative of 1 over y? Did you guess it? Good for you. That's our formula of the ln natural log of y, absolute value, equals, okay, on the right side, the antiderivative of x is just 1/2 x squared, and I'll put my constant c there. All right, well, now, here's the tricky part. Now I have to solve for y. And to get rid of that ln, this is a really important step. So I'm going to put a star right here. Because we do see the ln comes up every once in a while in the AP, and you have to really feel comfortable with this step, folks. All right, in order to get rid of the ln, I need to undo the ln. And do you remember the opposite form of log form is exponential? You're right. So basically, this is ln of base e. So I need to rewrite this in terms of exponential. This is the same thing as the absolute value of y equals e raised to the entire right side. That's 1/2 x squared plus c. Okay, that's a really big step there, friends. So make sure you're comfortable going back and forth between log and exponential form. There you go. Now, this next step is even weirder. Check this out. Off to the side here, here's my brain thinking. Do you guys remember when we had two bases and we're multiplying, and the bases are the same, what do we generally do with those exponents? We add them, right? So whenever you're given the same base, you take your powers and you can add them. Well, I'm going to go backwards. I'm going to argue that if I see one base and I see powers being added, I can split it up into two of the same base with each individual power, right? That's actually legal. We don't do that much. We always go forward, but I'm going to actually go backwards. And here's why. Right back to what we had here so far, guys. Do you see that my exponents here are being added? So do you agree I can go backwards and call this e to the 1/2 x squared times e to the c? That's the same thing, right? Because if I was to go the other way around, if I was to go left, I would be adding those two powers, and I would be back to here. Okay, here's another weird thing. Ready? E is just a number, right? That's 2.72. C is a constant. That's just number 2. So do you agree that e to the c is also just a number? So guess what we're going to call it? We're going to call it another new constant. We can call it C1 or C2 or just another c. And in fact, I'm just going to call it a c. Because again, AP does not get too picky about what's C1 or C2. So because e to the c is just a number, I'm just going to rename this whole thing as just one big number c. So really, the absolute value of y is e to the 1/2 x squared times, well, e to the c is just a big constant c. And generally when we're playing with e or trig or other things like that, the constant can go in the front. So there you go. I'm going to put another red star there. That's a really big, important step, guys, to feel comfortable about. I'm not doing anything that you haven't heard of before. It's just been a while, and we never thought about it this way. Okay, we're almost done. Now we just need to get the y by itself, but it's broken up by absolute value. Remember when we solved absolute value, that just means I have either a plus answer or a minus answer. So final step here, y equals plus or minus c e to the 1/2 x squared. Final answer. We solved the differential equation of dy dx, and we got y equals. So again, a couple important steps. We took the antiderivative, and remember over here, we used the ln from the formula. And then to transfer from log mode to exponential mode, we needed to write it like this. And then we did this nice little magical thing over here where we broke apart our addition in the exponents into two same base being multiplied. And then I rewrote it, e to the c is just a number, so I rewrote it as a constant. So he really turned into this. And then final step, here's your differential equation answer. That's the answer for C. All right, if you want to try D, if you saw in the previous video, we're going to have to get the y prime by itself, but go ahead and try it on your own if you want to pause the video right now, and I'll work through it with you together soon. All right, here is D, folks. Again, anytime that you want to go faster than me and get ahead of me and see if you can answer it, and then you can just check your answer, that's great too. But I would say this is probably the most complicated thing we have left this year. So it's great that you're taking really good detailed notes and even writing down some of the words that I'm saying to help you, as if I'm right there teaching you. All right, friends, D is 4y times y prime minus 3e to the x equals 0. Remember off to the side that y prime is the same thing as just the derivative of y, or dy dx. So I'm going to rewrite them. So that's 4y times dy dx minus 3e to the x equals 0. The reason I'm doing that is because I do want to get the dy dx on the left-hand side all by itself, which means on the right-hand side I need to get, again, some kind of x on the top and some kind of y on the bottom. So I'm going to do a little bit of algebra magic. Here we go. Let's start moving things around. I'm going to add the 3e to the x, and I'm going to divide by the 4y. How about dy dx equals a positive 3e to the x divided by 4y? The good thing is the x function is up on top, which is what we want, so he's diagonal. And the y function is on the bottom, so he's diagonal. So we can go ahead and cross multiply. Here we go. Ready? Let's cross multiply, and we get 4y dy equals 3e to the x dx. Good. Y is matching, x matching. Let's take the antiderivative both sides. Integral, integral. The integral of 4y dy, there's a couple ways you can think of it. You just do reverse power rule. But basically it's going to be 2y squared. The c is going to go on the right side. Becomes, well, 3e to the x is easy because e to the x is easy, so it's just 3 times the antiderivative of e to the x is just e to the x plus c. Awesome. Okay, this is looking good to go. And actually, algebraically, this is not too bad. Let's go ahead and solve for y. Divide by 2. And you agree that if I take a constant and divide it by 2, I just get another new constant. So if you want to, we can call that a C1 or a C2, or again, just call it a C. It's not a big deal for now. And then last final step, why don't we take the square root? So y equals, don't forget it's plus or minus, the square root of 3/2 e to the x plus c. And there's my answer, folks. That one's not too bad. All right, I'm going to do example number 2 next, where I'm going to have to again solve it, but it's a pretty easy one. So let me give that to you. And why don't you go and try it on your own if you want to pause the video. And it looks like this. Dy dx Let's consider example number 2. Example number 1 had parts A, B, C, and D, same instructions. Example number 2 is the same idea. Here's dy dx equals x squared plus 1 over 3y squared. All right, go ahead and pause the video, folks. Try this on your own, and then we can double check the answers together in just a second. All right, I'm going to double check right now. The x function is up on top. The y function is on bottom. I am happy. So cross multiply. 3y squared equals x squared plus 1 dx. The y's are on one side, x is on the other. I'm ready to anti-derive. Okay, here we go. Reverse power rule here. I got y cubed. Put the constant on the other side. Equals, how about 1/3 x cubed plus x? Is that okay? That's the antiderivative there. Plus c. And nothing tricky here. Let's just solve for y by taking the cube root. We don't need plus or minus because it's a cube root, not a square root or an even root. And that's it. All right, so again, try to get the x's on top, the y's on the bottom, cross multiply, take the integral on both sides, anti-derive, and just try to solve for y, guys. Nothing too crazy on that one. Good. Let's try one more together where we're actually going to try now to solve for this mystery c. What is c? Can we actually find what the number is? But we're going to need some given information to help us out. So here is, folks, example number 3. Okay, I want you to find the solution of this one. What's the solution for this differential equation? Notice instead of y's in terms of x, this is x in terms of t. So we want to actually solve this differential equation for x now. But I'm also given that at 0, the x value, which is kind of like the y, is equal to 1. So how can we use that to find what c is equal to? Remember, we used to do this when we first did antiderivatives way back in chapter 4. All right, let's start over here on the left side, folks. We've got dx dt. Let's get him all by itself. And now, can you see which variable do I need on top and which one do I need on the bottom? So let's just start playing with it. Okay, that's pretty good. I got the dx dt on the left side. Now, I need to have the x all by itself on the bottom, and I need to get any t up on top. Whoa, look at the power on the e. That's a negative power. Why don't we bring him upstairs? So how about the x stays on the bottom, e to the negative t, he can go back upstairs and become an e to the positive t. And you can see now that the t's are diagonal from each other, and the x's are diagonal. So we're exactly where we want to be. Let's do a big cross multiply. I get x dx. Notice I'm putting the x on the left side because that's kind of like the y in this equation, in this problem, because we're going to solve for x. X dx equals e to the t dt. All right, everything matches. Here we go, integral. This becomes 1/2 x squared equals, well, e to the t, that's nice. That's just e to the t, and there's my constant. Now we're solving here for x. Let's multiply everything by 2. How about x squared equals 2e to the t plus 2c. C got really small all of a sudden. Budget cuts, I guess. But why don't we change that? 2 times a constant is just going to be another constant, whether it's a brand new one or not. I'm just going to call it another c. And then last step, why don't we go ahead and take the square root? X equals plus or minus the square root of 2e to the t plus c. Okay, that's great. That's my general solution for this differential equation, but I need to actually use the given information that I have over here to help us solve for c. What is c equal to? So I can use this given information. I can plug 0 in for t and plug 1 in for x. Now, do you notice right now, guys, that the x value is 1, which means it's a positive number, which means if I actually look down here and I'd say, well, which one is this, a positive or negative? Well, if I get 1 out when I plug in 0, that means I can't be using the negative, right? I can only be using the positive. So I already know part of my answer. I already know that my answer is going to be the positive square root of and not the negative square root of. Well, let's keep going. So x is 1 when t is 0. And our job is to solve for c. Let's keep going. 1 equals the square root of, e to the 0 is just 1 times 2. And we can square both sides and do all that algebra magic. I'll tell you right now that c is equal to -1. Good. Ready? Final answer. What is the solution to this differential equation with c in place? X equals, not plus or minus anymore because we know it's a positive now by what we found out, the square root of 2e to the t plus c. And what was c? -1. And there you go, guys. That's a good one. So we found, again, the general antiderivative. And like we did way back in chapter 4, we can actually plug in the values for x and t, solve for c, and plug it back in. Good. I'll give you one more video with 2 more problems you can try just to test out if you want a little more practice. Good job, everybody.